Welcome back, everybody. Today's the 5th week of this training, and today we will talk about NumPys, pandas, and data visualization. Of course, if we don't have much time today for pandas, we will just focus on NumPy and data visualization. Okay, but before that, instead of using this VS Code, I think the best way to use NumPys and pandas is actually Anaconda. So you should first install Anaconda. As you can see, it's installing. Of course, I installed it already, but I have to show you the steps. And you just wait for some time. So there are some things open, so I have to just close I have to close this. And we don't need this one also because after this, we are not going to use the Visual Studio Code. So I will close it. Maybe if there is something I wrote. Okay, nothing. All right. So now, as you can see, the downloading is completed. So what you should do is just click it, and then wait for some time. And then next, up to the end. And then you will complete the downloading. So for me, since I do have already an Anaconda, I don't have to install it. So I have to abort this installation. Yeah. Okay. Yes. Great. I hope this was easy to follow the installation process. Then now the second step is actually how to open Anaconda. Just you write Anaconda. As you can see, I have here Anaconda. Great. So just wait for it, and it just pops some dialog box, and finally it opens just a web browser on the web browser with some server or what is this? Yeah, I think it's opened already now. As you can see now, I have this Anaconda Navigator. That's great. Actually, Anaconda Navigator comes with lots of tools. This the CMD prompt just opens the CMD, and this is Data Lore. It's an online platform for data storage. And then this is IBM Watson Studio, Jupyter Lab, something similar to Notebook. But I'm in favor of Notebook, and actually Orange. Orange, you don't have to know programming or coding, but it allows you to do data analysis, data visualization, and machine learning. I would recommend you to also check out Orange. Out of the box, it just does lots of things for you. Yeah. Thing is, that's really somehow impossible for you unless you have a very strong understanding of machine learning. And yeah, then so as you can see, PowerShell, you can access the PowerShell Qt console. Yeah, PyQt, it's a graphical user interface for Python. Spider, it's another way also to open the so all these are somehow similar, and VS Code, as you can see, glue visualization, I've never used this, and PyCharm, another Python code editor, and RStudio for R. Okay, but now I'm interested on Notebook. Let's give it time, and Notebook will be opened on a server. Have you seen this port? So it's open this at this port. We don't care at what port it has been opened, but as you can see, what you see here is actually your computer. Have you seen my desktop, documents, downloads, and whatsoever? Something you have on your computer. And what I see is something what I have on my computer. So I go to the desktop. Great. And then which one is our folder? Our folder, as you know, which one is it? This. Yeah. Yes. So now in the week 6, so I can't create a folder like this, but I can create like this folder, and then I call this, and then rename it. What's the name? Week 6. Yeah, so that means now I created a folder. So I click this one, I opened it. Inside here, I can open. I can create a Python file, or a text file, or a folder, or even you can open the terminal. But I go for Python. Yes, I call this one week 6 and week 6 and Jupyter notebook tutorial or practice. Great. So you can give it any name you want. And now wait, but it is 6, week 6. Or even we don't have to call it that, just place Jupyter notebook. Why is like that? Notebook practice. It's a very good name. Yeah, I rename it. Now, as you can see, a very nice cell is waiting for you to write Python script over here. And of course, you can navigate, as you can see, if you click file. So either to make a copy or to save or to rename, it's just as usual, you know. So you can edit something, you can undo, so for instance, or delete the cell, whatsoever. For instance, I may show you. So I can say print, I love notebook, Jupyter notebook, and then control, actually it's not control, shift, enter. Yes, I love notebook. If you want to create more, you can just press the shift and enter. I'm creating more of them. As you can see, yeah, it was by mistake. And then if you want to delete this part, you just come here, cut it. Or even you can come here with the delete cells, but that's too far to go, right? You can just do this. Yeah. So it's so easy to use. And then you can also use this run to run the cells. And sometimes it's like if you want to just to restart the whole notebook, you may use something like, do you want? Yes, restart. But I have only one cell here. You can use just 1 + 2, enter. Yeah, 2 - 1, as you can see. 2 × 3, 6. And 3 divided by 4, everybody knows. And 4 modulus 3, I'm expecting 1. And again, 4 lower floor division by, I'm again expecting 1. And 4, what do you expect here, guys? Tell me.
Sixty-four.
Yes. Great. So as you can see, it's just a normal editor to write Python. Again, sometimes when some cells is not working, you can just executing from top to bottom. Just you select this part and then again, Control Enter. then fixed. And maybe if you want to create another cell in between, then maybe you can also just add some note. For instance, this is markdown. You change this part to markdown, okay? Oh yeah, so you may say multiplication. Yes, and then shift enter. And then as you can see now, this I'm just helping you to how to use division. Yes, and yeah, it goes something like that. But it's not only that. For instance, whenever you start all the time, for instance, this is the beginning. If you want to add, I think that is shift B, or it's control. Yeah, so as you can see now, even I forgot the shortcuts. So you go here and shortcuts, keyboard shortcuts. And you just see, yeah, a pin, for instance, a pin. Yeah, insert cell, as you can see, insert cell above, below. So Control A. If you see Control A is at select all. Just yeah, select all, of course, but A or B is actually to insert above or below. B is below. Yeah, look at now. If I just press so to press this, it should be like blue like this. Now, if I press A, I will have a cell at the top. Have you seen? Have you seen the cell? And again now, yeah. Again, you have to click outside and change this from green to some kind of a blue. And yeah, and now it's like that. Then if I do B, actually below the cell. Have you seen below the cell? So don't force yourself to remember all the shortcuts. Just go here and then you will get all the shortcuts here. And through process or it will become second nature. Yeah. Now let's add something. I can say Numpy is a Python numerical tool or something. Yeah, if you do something like this, of course, it will be an error, as you can see, invalid syntax. You have to change this to markdown. Yeah, I have to change to markdown. And now, yeah, so now I have a title. So in this case, you can document everything you do with the text, just standard text. Okay, I think by now you have an insight how to use the Jupyter Notebook. It's easy, right?
For now.
Yes, and even to install packages, you don't have to go to this, the CMD, like Pip Install Numpy. At the first place, Numpy, Pandas, all those basic packages are already installed in here. So if you go to here in the environment, have you seen the different packages already? The notebook and this, the Anaconda have you seen? So all the important packages are actually already included. So you don't have to like install by yourself. Yeah. Yes, that's the importance of using Anaconda. The most common, the most important packages related to data analysis, data science, machine learning are already in the Anaconda, this package, Navigator. Great, people are joining now. So what are we learning today? So I will teach you today about NumPy. So this is the official documentation or website of NumPy. So let's see what does it says there. Yeah, as you can see, NumPy as of today, or is that as of this day, the version of NumPy is 1.210. Okay, so now what's NumPy? Let's read from here. Sometimes it's good to just get the information directly from the source. NumPy is the fundamental package for scientific computing in Python. It's a Python library that provides a multi-dimensional array of objects, various derived objects such as masked arrays and matrices, and an assortment of routines for fast operation. Yes, fast operation. Actually, it's very powerful. It for fast operation and also for storage. It actually it just doesn't take much space, and it's also speed is so fast. On arrays, including mathematical, logical, shape manipulation, sorting, selecting, input, output, discrete Fourier transforms, basic linear algebra, basic statistical operations, random simulation, and much more. So this is what we're going to see, guys. Yeah, it's a very, very powerful tool. Okay, if you have time, I think you might have been in this material. So today we will go through this step. Maybe I have to put it in the other screen, and if I get lost, I will have a chance to look at. Then now let's start creating a new file for you here. So how do I create a file now, guys? I come here, and then I call just guys, and also it's a very good practice to give it a name here, because pandas, this Jupyter notebook makes you so lazy because it works untitled, and if you have hundreds of untitled, then you will be really messed up. So it's better just to give random name than just untitled 1, 2, okay? So I just call this NumPy for the time being, and yes. Then actually even you can install like this, pip install NumPy. But as I told you, NumPy is a very, very common package. Of course, Anaconda had it already. But if you don't have, for instance, NLTK is a natural language processing package, so you can install it like this. Pip install NLTK, like this. And just wait for some time. Yeah, actually, since I installed it already, it just tells me that it's there. Okay, so let's write note NumPy. So in short, what did we say? I think I can just copy from the GitHub information. As you can see, NumPy stands for numerical Python and is the core library for scientific computing in Python. So this is really very important. Yeah. So we have to change this to Markdown. And now we have some note at the top. Now it's time to import NumPy. Yes. So we imported the NumPy here. Okay, but guys, as data scientists, machine learning specialists, whatsoever, those people usually, they want to make this a bit shorter. Import NumPy as NP. This is how they import it. So let's check the version actually. Print num version, because the version that as you can 1.19, but I think we're behind a bit. Let me check. I have seen 1 to 1.0, but it's okay. Yeah, so you can update it, but now I am a bit behind. Mine is 192. It's okay. Let's move on. Then, how do we create a NumPy array? Creating NumPy array. To create a NumPy array, we need a list. We may create a NumPy array from list or tuple. Yeah, but why we need a, you may wonder that then list is already like NumPy array, because as I told you, it's very, very fast and it doesn't take much space as a list, ordinary list. So in terms of performance, NumPy is much better. So let's create a list. Very simple. So 1, 2, 3, 4. What's the length of this list? By just looking at, tell me guys, I think 4, right? Create type of list. As you can see, the type is list. But to create an array, we can say numpy.array. Then you pass the list over here. Yeah. Then I may store it somewhere. Since it's an array, so we call not numpy list, we call it numpy array. So print the array. As you can see, it's a bit different. If you print this one, yeah, the list looks when you print usually with a comma, but this without a comma. And let's also check the type of the array. As you can see, it's a numpy and a dimensional array. Right now, we have already created a numpy array. Is it clear so far, guys? Okay, yeah. I hope so. But now let's make it a bit, making this a bit more list of lists. List of lists. That means if I have 1, 2, and if I have 3, 4, and I have 5 and 6, I have a question. How many elements do you have in this list of lists?
3.
Yes, great, 3. That's great. So now let's change this array, and then numpy.array list of lists. But we have to print these things. Then it's hard to know. Yes, and the type. List of lists. And this one also the type, the array. As you can see, the first one, we just got the list of lists, what we wrote, and the type is list. But the second one is actually, it's a kind of a matrix, as you can see. Like the value, this value, the list of lists has been changed.
The spelling of print in column 10, number 6 is not correct. That's why it's this error.
Yeah, okay. Thank you. Yes. As you can see, we have for the array, we have like row and a kind of a column. Yeah. And the type is actually NumPy. Okay, now this is actually two-dimensional array. And this was one-dimensional array. One-dimensional and two-dimensional. But we don't call this dimension, instead list of list. So now, just to make some analogous, I can call this two-dimension array. Then my students can understand without a problem, because the variable name by itself speaks. Great. Can we even go further? Like list of lists, and let's try, let's just modify this a bit. And if you see now, for instance, even we can add, like if you just add extra one, this already made it actually a three-dimensional array. Okay, let's check. List of lists. And then actually there's a method, I will come to that later, but I won't also use it now, ndim. Ndim is actually to check the dimension. As you can see, it is three-dimensional. Okay, great. So the more nested list it gets, so the dimension increases. I hope you understand that way. Yeah. I think another thing is actually we can also determine the type, the data type, when we create the values. For instance, if you say numpy dot array, and if you have 1, 2, 3, and you can decide the data type. By default now, the data type will be, as you can see, 1 to 3, but you can pass another argument, dtype, you may say int. Yes, it's int, of course, by default, but how about if it's float? As you can see, it's a floating number, yeah? But how about if I say Boolean? A Boolean instead of Boolean, bool. How about if I say bool? It's going to be actually true, true, true. That's what I'm expecting. Yes, because I will show you something here. Every positive numbers are true value. Strings and everything are true value. Then what is false value? False value is actually 0. 0 is a false value. So let me show you now. 0. Now we have a false value. Let me try -1. Yeah, even -1 is also, as you can see, a true value. So you can create, now as you can see, we had numeric list and we changed it to a Boolean. So sometimes you may need some problems to solve it this way actually. So we can create NumPy arrays with different data types, but also actually we can change after it created already. For instance, if you have already an array, and then I may have array, and if you have already one 2, 3, 4. So you have already. Then you may say array as type to float. You can change it. Then as you can see, it has been changed to a float. Yeah. You can change it to bool, and then it will be, as you can see, true. But to know if you just put 0 here and somewhere 0, 0 means a faulty value. Yeah. So we can change the original to something else. But do you think the original has been affected? Let's check. So the as type doesn't affect the original. So you have to store this to a new variable if you want to store it, okay? Yes. That's how it works. Great. Do you have any question?
Yeah, one question. I was just thinking that if there was a null value, it would be basically 2 commas together without any digits in it. I thought it would be false C value, but apparently it gives me an error.
Okay, so let me see. Is it what you asked?
Yes.
But it doesn't support it that way because this is already a syntax error, as you can see.
Yes, yes. Yeah.
Because this, this is in JavaScript, we have this destructuring with something like this. Yeah, but that's a very good assumption. Maybe if you have some null value, let's see, no. Yeah, none, as you can see, it's also a faulty value. And if you have this something empty value also, I may guess this is also going to be a faulty value. But if you have some string, I think this is going to be a truthy value, as I said. Finland. Yeah, I forgot the. Yeah. So now if you see the faulty values, none, 0, null, or just empty string, and none. Yeah, this is what I know so far, but also let's figure out Python faulty values. I prefer this one, Stack Overflow. It has been asked, what's the truthy and falsy? How is it? I think that person just, all values are considered except for the following, which are falsy. None, yeah, so none are false, 0, 0.0. This, as you can see, also a complex number by itself. And decimal, I've never used this. And an empty list, as you can see, an empty dictionary, an empty tuple, an empty string, and an empty bytes, and an empty set. All these can be falsy values. Yeah. Oh, great. So sometimes these faulty values might be tricky, so you have to do such kind of a reference. It might be hard to remember all of them. Yeah. Great. Let's move on. Complex, for instance, can we create complex number? Like if you say, if you have this, let's see, a numpy dot array, and then if you have 1, 2, 3, 4, and we may say the data type we want to be complex. Yes, And then, as you can see, a complex number has been created. Actually, it just add, as you can see this, yeah, you know, complex number. If you didn't remember a complex number, just leave it, it doesn't matter. But the point here, you can create any kind of data types as an array. Now I have here an example. You know that I like fruits, don't you? I know everybody likes fruit. So these are tropical fruits. I think this might not be, but most of them. Okay, so now let's change this to an array. Array, Untitled array, then fruits. So far, you may not notice the importance of changing this list to array because we didn't cover much things yet, but you will notice that soon, okay? Yeah, now as you can see, I changed it from a list to an array. Then you may ask, then what? Yes, so then what? To get the then what answer, we should just wait a couple of minutes, but just follow me now. Okay. NumPy arrays has attributes. Okay, what's attributes means? Like you, for instance, I was saying that instead of rewriting it all over again, I may just use this example, the list. Okay, let's make this a title. I have a list and now I'm about creating an array. And then I say array. This is now, I have an array. This array has attributes and methods. For instance, if I say size, actually size is almost similar to length. As you can see, 1, 2, 3, 4. Okay, great. Then shape. Okay, the shape is actually, as you can see, it has 4 columns. 1, 2, 3, 4. Okay, what's the dimension? I expect the dimension is 1. N dim. As you can see, it has just 1 dimension. So, and even you can get the bytes of each element item. Then you may say item size. Yeah, it's just 4 bytes. Okay, great. So we can do like this. I wrote, by the way, even you can create a single element. Like for instance, in Python, in normal Python, we say, okay, 10 is equal to 10, right? We store now in print 10. Yeah, but we can also just do a single like 10. But this is actually a NumPy array, even though the values are 1. How is the dimension? N dimension. Yes, 0, because it doesn't have any dimension. So it has 0. And the shape, if you check also the shape, I think, as you can see, it doesn't have any shape. Of course, the item size, yeah, the item size is 4. Okay, you can also check the data type, and everybody knows the data type for this, and it's an integer. Okay, so as you can see, I have been writing every attribute. So I wrote a function that allows me to find this function. I will show you here. Actually, this function takes an array, and then it gives me the dimension, the shape, the size, and the data type and the item size. So I don't have to like write and delete at the same time. So what I can do, get NumPy info. Now, if I just pass 10, as you can see, yeah, the dimension is actually 0. The shape, it doesn't have any shape. Size 1. Data type integer. Item size 4. Yes. So now if I pass, for instance, this array. No. Yes, the dimension is 1 because this has just one dimension. You may just also have a look, print array. Yeah, it has just one dimension. And the shape 4 and 0, this actually means when it doesn't have any additional column, so it just show you only the, rows, just show the columns. So it has 4 columns. Data type integer, item size 4. Okay. So now we learned that this dimension, shape, and size and item size. Maybe I think a very good example now to make is actually this one, list of lists, because it's a bit different. Okay. List of lists, then 2-dimensional array, right? And np.array, please pass the list of lists. I know this thing is very simple. Get info, then just pass 2-dimensional array. As you can see, the shape of this is 2, so it's 2-dimensional. If it's list, of course, it's going to be 2-dimensional. And the shape is actually 3 rows and 2 columns. Let's see, what does that mean? Print, it's better to print here. Print the 2-dimensional. As you can see, how many rows do you see? 1, 2, 3, so 3 rows. How many columns? 1, 2 columns. Size means actually all the elements. 1, 2, 3, 4, 5, 6. Data type, the data type of all this int type. Item size of each element, it's 4 byte. Great. That is now, for instance, we can also convert the NumPy array to list actually. So we can use the toList method, for instance, toList. Now this has changed from an array to, if you check this, let's check this print. Yeah, it's list. So we can use the toList, a method to change from an array to list. Yeah, great. Another way to do the same, creating a NumPy array, we can use tuples. Tuples, how do you create a tuple here? Just, hey, tuple, 1, 2, 3, 4. Yeah. Do you agree this is a tuple, guys?
Yeah.
Yes, it's the tuple. So the difference between a list and a tuple, once if we create, we can't modify it. We can't mutate it. It just will be the and there are just few methods to deal with tuple. So now np.array and then tuple. As you can see, we have created an NumPy. Yes, maybe how about if we had something like this? Tuples inside another tuple. So this is common, by the way. You may have something like this. Yeah, as you can see, I'm having now, as you can see, 2 rows and 2 columns. And so the dimension is going to be 2-dimension. And the shape is going to be 2, 2. This is, you can just check shape. two rows and 2 columns. All right. Now, iterating. How do we iterate through the items? Iterating. All right. Yeah. I have to make this too. Actually, title. I think it's very tiring to create list now and then I have to go here. This is just an ordinary list. So if I want you to iterate through, you may say one of the item in the list, right? And then you may say print item. This is very easy for you. Yes, actually it's the same in NumPy array. Let's do that. If you have just first NumPy, array and NumPy, array the list. Of course, first you may see what do you have here. As you can see, we have an array. So we can iterate through this. For item in the array, and let's just print the item. What happened? Because it is not array, it's just AR. So we got the same thing. But how about if we have something like this, list of lists? Now we have list of lists and we will get also 2-dimensional array, right? And p dot array and list of lists, right? Then for, yeah, just item, one of the item in 2-dimensional, then you just print the item. I just want to ask you, what do you get from this? Before I print it out, I want to know what you think about this. What is the item represent now?
List of lists.
So 3 items, 1, 2, 3, 4, and 5, 6. These 3 items.
These guys, right?
Yeah. Yeah.
Yes, these guys, the 3 items. So you will see the 3 items, as you can see, this one, this one, this one. Okay, now even if you want, so you have to go one deeper for X or for something for X in item, then printed X. Now, as you can see, we managed to print out everything. But actually, there's this method, instead of going like that, for item in, we can say NP, and the enumerator. Yes. So as you can see, NumPy and the enumerate, it give us this, actually the index or the position of each item. It's a very good method. No, I don't need that, but 2-dimensional. Okay, let's see. Print item. Now, as you can see, the position and the value. So as you can see, you got now. I want to ask you, what are we getting here? What is this? A tuple, right? Tuple.
Matrices.
Yes, we have a tuple. So inside the tuple, we have another tuple and an element. So if we are interested to this value, actually we can say, for instance, you can use indexing, and if you just say 1, actually I can get that value. So I don't have to go nested loop like this. Yeah. Yes, great. By the way, if you don't know enumerate, for instance, if you have 4, you may say you have a value again, because you may not remember enumerate. Enumerate. Okay, you have this 4x in list, right? Print x. Now you manage to print from 1 to 4, but you don't know the index of these guys or these items. So sometimes you might be interested in the index. In that case, actually, you should use the enumerate. Enumerate, it's a function, a built-in function that allows you to get the index. Now, this will be, x will be a tuple. Okay, let's see. Have you seen it becomes already a tuple. Now, what are we? This is the index and this is the value. So you can just actually, you can say index and item. So I'm destructuring it here already, okay? So index and then the item, as you can see, yes. So we have also in NumPy this n enumerate, n dimension enumerate. Great. Now let's go to the fun part. That's the mathematical part. Mathematical part or mathematical operation. Okay. Then you may be surprised here. I tell you, you will be surprised. Okay, because we've been working the hard way before we get introduced to NumPy. For instance, if I ask you to double this value, these items, you may use some kind of a function or a list comprehension or a higher order function, right? Most probably you may do list double, you may say for x in list, and then you may say 2 times the x value, and then if you print list double, yeah, we doubled it, right, using list comprehension or just some higher order function with lambda or something with a map. Yeah, or if you want to square it, you can also say by squaring it in. Yeah, something like this. But in list, let me show, and in a NumPy array, you have this. Now let's create an p.array. Okay, I have created this. Now, if I want to just multiply this to double the value of each item, just what you do is actually just multiply it by 2. Have you seen this? You might be just shocked, I tell you. If you don't get shocked when you see this, then I think, because we've been writing a lot of codes to achieve this before, right? If it is list, yeah, you should do. But now, NumPy array, you can just divide or multiply or do whatever, and every item changes. Okay, so now let's do addition, for instance, array, on this array, plus 10. I want to add 10. So array plus 10. Array plus 10, let's check. As you can see, if you add 10, 11, 12, 13, 14, crazy, yes. And then if you say again, array minus 10, and then I have to have the original array minus 10. Print array minus. Okay, let's subtract 10 from this. Minus 9, minus 8, minus 7, minus 4. Yes. then array times maybe again 10, because that's easy to see. Then array times 10. Yes, as you can see, 10, 20, 30, 40. Oh, great. Can we divide? Array division by 10. Okay, then I want to know what's the value for this. The value for this 0.1, 0.2, 0.3, and 0.4. Yes. And then quotient or modulus, remainder. If you want to say remainder when it divided by remainder, for instance, array by 10. The remainder should be something like this. But the problem is the remainder for all this will be like itself, because there are small numbers. So I can change it to, if we divide it by 2. Yeah, so the remainder, I will say 1 divided by 1, the remainder is 0. And then again 0, the remainder is here 1, and then the remainder is 0. Okay, let's see. Yeah, 1, 0, 1, 0. Again, let's do floor division. Floor division. So let's divide the floor division. And what do you get when you do a floor division with this number? 1 by 2. 1 by 2. One is not divisible by 2, right? Then it's going to be 0. So 2 by 2 and 0. 3 by 1. 4 by 2, 0. Let's see. Yes, you can see 1, 0, 1, 0. Okay, then exponential array. Let's let's give it the power of 2 and 1, 4, 9, 16. So as you have seen, it is so easy to do mathematical calculation using NumPy array. Yeah. And it's not about the simplicity, but it's also all about the performance and the memory size of the data. It just stores small. It doesn't take much memory, and the speed is so amazing instead of an ordinary list. Okay, so now, for instance, since you know already how to do, let's import the matplotlib. Import. If you don't have you can just say, I can show you Pip, but you don't have to, because we are working on Jupyter Notebook. It's already, we have already Pip matplotlib. So, but we have it, so you don't have to do that. What we should do, import matplotlib.pyplot as PLT. And you have to do this because I want to show you the power of this. Okay. Now I'm say x equal to 1, 2, 3, 4, 5, 6. Yeah. Maybe I can go 7, 8, 9, and 10. Yes. Now, for instance, to write an equation, y is equal to 2x plus 10. Do you think is it hard to write this equation using NumPy?
No.
No, because NumPy is so smart. Now, even it's also good to change this value to a NumPy itself, because you can just NumPy array and you can just put it inside. And then you have this NumPy. Then what you should do? Why, first, let's see what we have at x. As you can see, you have 1 to 10. Then y is equal to 2 times x, this value, plus 10. So for 1, we are expecting 1 times 2, 2 plus 10, 12, right? For this one, for the last one, actually we are expecting 2 by 10, 20, 20 plus 10, 30. Let's see. Of course, I should have printed out range x, y. As you can see, this is 12 and this is 30. So our calculation is actually correct. Now we can use matplotlib just to visualize plt dot scatter maybe, or plot x, y. And then as you can see, we got some line over here. So our points are from 1 to 10, and our values, the dependent values are from 12 to 30, as you can see. Yeah. Then if you also just change instead of square, if you change this to also something like this, it will be somehow parabolic, as you can see. The reason why it's just like this, it doesn't have a negative value. You can add negative value -5 and -4 and -3, -1 and 0. So in all sides, now as you can see, kind of, because this is going up to 10, but this starts from 5. So it doesn't have a kind of a symmetry. So actually it's not a very nice way to write this way. So why don't we use just NumPy range? So I will show you. Do you remember range? Who remembers the range? It has start, end, and step. Do you remember range in Python, guys?
Yeah.
Yes. For instance, if you say just
100 step 2.
Yes, for instance, if you just say like 11, you have from 0 to 10. Yeah, maybe I can show you. I want to help you too. Yeah, but the problem here, you have to change it to a list. Yes, you have to change it to a list. Yeah. So maybe if you don't want to start from 0, you can just start. And if you don't want to just step by 1, you can just step by 2 or 3 or by whatsoever you want. Anyway, now you got what range means. In NumPy also we have NP arrange, not range, but arrange. Okay, the rest is the same. Yeah. So now after this, we don't have to write this, but I can say NP arrange from -10 to 10, as you can see. And then I can just say, have you seen now? It's just beautiful. But the problem now, this one is the starting point, but this is not the ending point. So I have to be a bit smarter. Yeah, now you see a symmetry. Yeah, so the starting point is -10 and the end point is 10. So this is actually a quadratic equation, and the equation is actually x squared plus 10. So it's a symmetric parabola. Yes. Okay, but you can just change this line also to plot. And it will be just a line. And now have you seen the power of NumPy? Yes, I hope so. Let's just move on. Okay. Now let's see indexing, because we didn't talk about the indexing. Is it similar? Indexing, is it similar to list? Yes, it's somehow similar to lists. I think before we move on to indexing, we have to have a 15 minutes break, and then we will move on to indexing after that. Okay, see you after 15 minutes.
Okay.